Most people think this. The GC runs because there is a lot of garbage. That feels reasonable, but it's not how the runtime thinks. Let me show you why. I'm K1, welcome to my channel. In the last video, we learned objects don't die when methods return. They die when nothing can reach them. So the real question is, what actually forces the runtime to clean that memory up? As I said at the beginning, most people picture it like the GC runs when there are a lot of dead objects. Even the name nudges us toward that idea. Garbage collector makes it sound like something that occasionally goes around clean up trash. But that's not really how the runtime works. Look at this method. This allocates a lot of memory, then returns. At that point, every one of these arrays is unreachable. Nothing references them anymore. But the garbage collector does not run just because of those objects are now dead. The runtime doesn't pause and ask, are there dead objects now? Imagine this happens during startup. The app allocates some memory, then sits idle waiting for requests. Nothing else allocates. In that situation, the GC may not run at all. Thousands of objects can be dead and nothing happens. So, if the runtime is not looking for garbage, what is it looking for? The real question it asks is, where does the next allocation go? As long as there is free space, allocation is extremely cheap. The runtime just hands out the next chunk of memory. But eventually, that space fills up. At that point, the runtime has a choice. Ask the OS for more memory or reclaim memory it already owns. Reclaiming usually is cheaper. So the runtime pauses execution and looks for objects that are no longer reachable. That pause, that search, is a garbage collection. Consider this code. Nothing here ever becomes unreachable. Everything is still referenced. And yet, the GC will run again and again. Not because object died, but because the runtime keeps asking, where do I put the next allocation? In the first example, everything died and GC may not run. In this one, nothing dies and GC must run. That's the difference. When a GC starts, conceptually, three things happen. First, the runtime finds all root references, stack frames, static fields, and active tasks. Second, it walks the object graph from those roots. Everything reachable is considered alive. Third, anything not reachable is reclaimed. That's it. No guessing, no importance ranking, just reachability. At first glance, this looks harmless. We create an order, wired up a customer, and return. But this single assignment changes everything. By caching the order, we keep the entire object graph alive. The order, the customer, the order history, every order inside it. From the GC's perspective, there is one root, cached order. The GC doesn't see objects, it sees path. The runtime makes a simple observation. Most objects die young. Temporary things like link results, short-lived details, pre-request allocations. For example, this allocates a list, iterators, and temporary objects. Most of them live for milliseconds. Clean up young memory is fast. So the runtime applies different collection policies based on lifetime. Now the objects start in a young, short-lived region. Objects that survive get promoted. Now watch what happens when the lifetime changes. As you see, same code, same objects, completely different lifetime. This list is now rooted for the lifetime of the process. Not because it's large, but because it's reachable. Here's the pattern that looks harmless. Each request allocates a tiny object, Individually, they are cheap, but each one survives because the collector is static. Nothing breaks after 10 records or 100, but after hours or days, this service behaves very differently. One object per request, stored forever. The GC can't help you reclaim a memory you are still holding onto. So, over time, free space shrinks, allocation pressure increases, GC runs more often, and each GC does more work, same code, same logic, different pressure. Here is the sentence to remember. Let's read it in peace. From the outside, GC looks unpredictable, but from the runtime's perspective, it's not. It reacts to allocation rate, object survival, and available spaces. When memory pressure increases, the GC doesn't just run more often. It starts scanning more memory, compacting more aggressively, and pausing longer. And that's when memory turns into a performance problem. That's what we'll explore in the next video. How memory pressure turns into performance problems. Stay with me, grow with me. See you in the next video.